Okay, the derivative of, well, this is to what power? 1/2. So if I rewrite this using the properties of logs, this is x times 1/2 natural log of x, which is 1/2 x natural log of x. This is product rule, but I don't have a radical involved anymore. So what's f prime of x? Well, it's the derivative, it's 1/2 times the derivative of the first times the second plus 1/2 times the first times the derivative of the second, which is 1/2, derivative of x is just 1, times natural log of x plus 1/2 x times, what's the derivative of natural log? 1 over x. And then you can simplify.
So you don't have to take the derivative of that 1/2 at all, really?
No. I moved it out of the way using properties of logarithms.
Okay.
What's the derivative of 1/2 is?
It would be 0 as
Yeah.
a constant.
Yeah, so it's a constant, so it just comes along for the ride.
Okay.
Now, there's a couple of ways that you could deal with this. I think the easiest way is just to bring that 3 down. Now, u squared minus 1 happens to be u plus 1 times u minus 1. But let's go ahead and just do this. G prime of u equals 3 times 1 over the blob times the derivative of the blob, which is 3 times 1 over the blob, and the derivative of the blob is what?
2.
That's it.
That's it. It'd be a heck of a lot easier than 1 over u squared minus 1 cubed times the derivative of u squared minus 1 cubed. It clears those exponents out. This is where you really like it. Is this guy. This would be ugly. This would be 1 over that fraction times the derivative of that fraction, which is quotient rule.
Wait, it'd be 1 over the fraction over the fraction?
No, it'd be 1 over the fraction, 1 over the blob. The blob is this fraction.
Okay.
So it's 1 over that fraction times the derivative of that fraction, which is quotient rule. I know. However, we're going to rewrite L of x as the natural log of the numerator minus the natural log of the denominator. Isn't that much nicer?
Yes.
Now it's just 1 over the blob times the derivative of the blob. So that L prime of x is 1 over the blob times the derivative of the blob. The blob is x squared plus 2x minus 3. And the derivative of x squared plus 2x minus 3 is 2x plus 2 minus 1 over the blob times the derivative of the blob. In this case, the blob is x squared plus 2x plus 1, and the derivative of x squared plus 2x plus 1 is?
X squared, or 2x plus 2?
2x plus 2. Now, the simplification would not be a picnic, but we're not simplifying, so we don't care. Any questions? Now, the next problem has shades of the test. So here we go. In problems 39 through 46, find the largest and the smallest values of the given function over the prescribed closed bounded interval. What am I looking for?
Max and min.
What kind of max and min?
Absolute.
Absolute. So the minute I realize that this is an absolute max min problem, it only deals with the first derivative, and so I'm not looking for increasing, decreasing, concave up, concave down. I'm looking for only the absolute max min. There's my interval. I set up my T-bar chart, and I'm going between 0 and 1. So this is where life becomes interesting. So now I'm going to be finding critical numbers. So I'm going to come back over here and work with it because it's going to be a heck of a lot more work. So f of x is going to be e to the minus 2x, as innocent as this looks, minus e to the minus 4x. Looks innocent, not so much. So I need to take the derivative. It's e to the blob. And what's the derivative of the blob? Negative 2 minus e to the blob times the derivative of the blob. And what's the derivative of the blob? Minus 4. So simplify, it's negative 2 e to the minus 2x plus 4 e to the minus 4x. And I need to take that, set it equal to 0 to get my critical numbers. I've got a greatest common factor of negative 2. And what else do I have a greatest common factor of?
E to the negative.
No. What's the smallest power? Negative 4x. I'm taking the negative 2. From the e to the negative 2x, I am removing a negative 4x. Plus, and actually, yes, and that's not a plus anymore, it's going to be a minus. I'm removing a negative 2, so that plus changes to a minus. That 4 changes to a 2, and I'm taking the e to the minus 4x. So, minus 2 e to the minus 4x times e to the minus and a minus is a plus. Minus 2x plus 4x is 2x. Now, e to the minus 4x is never equal to 0. Ever. That means that e to the 2x minus 2 equals 0. E to the 2x equals 2. Now what? There you go. Take the natural log of both sides. So that 2x e, or excuse me, natural log of e equals the natural log of 2. So I can bring the exponent down in front using properties of logarithms. Natural log of e is just 1. So that 2x equals the natural log of 2, or x is the natural log of 2 divided by 2. And then my question is, I don't know what is a max min, don't care. I care whether or not that x value is in the interval. And the natural log of 2 divided by 2 is approximately 0.35. Is 0.35 between 0 and 1?
Yes.
Yes. So there's a couple of things that we can do with our calculators. You can go at hard and fast, that's one way. I can basically say it is going to be e to the negative 2 times 0.
Where's E at? Oh, I click on it.
And minus e to the negative 4 times 0. Now, by the way, it doesn't matter what calculator you do. If you do with little baby cheapy ones, that'll work too. And that comes out to be 0. Now, you have on all calculators a recall. If I do second enter, that'll bring back what I just did. And now I can go back and change that 0 to a 0.35. Enter. And I get a 0.25. And then I can come back again, change it to a 1. Whoops.
0.12.
Delete. Press the wrong button there. 0.12. Now, absolute max, 0.25. Absolute min, 0. It's Y values.